Hello, in this lecture we will find the size of angle X in two different methods. In the drawing we have quadrilateral SRPQ. We know that angle SRP, this angle, equals to 65 degrees. We also know that angle PRQ, this angle, equals to 50 degrees. And we also know that side SP equals to side SQ. And we want to find out the size of angle PSQ, this angle that equals to X. So we will start with the first method. With the first method, we will extend QR. We will extend line segment QR. And then from point S, this point, we will draw perpendicular to the extended QR line segment. So actually this angle equals to 90 degrees, and we will define the touching points between extended QR to the perpendicular as point N. In the next step, so this angle equals to 90 degrees. It is a right angle because SN, it is actually perpendicular to extended QR. Therefore, this angle equals to 90 degrees. And we will also, from point S, we'll draw perpendicular to PR, to line segment PR. So actually, this angle is a right angle, it equals to 90 degrees, and this angle is also a right angle, it equals to 90 degrees because S, we will define the touching point between the perpendicular to side PR as point M. So because of the fact that SM is perpendicular to PR, this angle equals to 90 degrees, and also angle SMP equals to 90 degrees, and angle SMR will be also equal to 90 degrees. And also angle SNR equals to 90 degrees. Okay? So QR is a straight line, and we extended the straight line QR. So actually QN will remain a straight line because we extended QR, that is a straight line, by a straight line. So QN is a straight line. Therefore, we know that the sum of the angles on a straight line equals to 180 degrees. That is to say, if we focus on point R, on this side of point R, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on a straight line equals to 180 degrees. So that is to say 50 degrees plus 65 degrees plus this angle that we will define as angle y must be equal to 180 degrees. So we can write down that 50 degrees, if we focus at point R, on this side of point R, the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on a straight line equals to 180 degrees. That is to say 50 degrees plus 65 degrees plus the size of angle y must be equal to 180 degrees, according to the rule that the sum of the angles on a straight line on one side of the straight line equals to 180 degrees. So here we will subtract 50 degrees from this equality, and we will get that 65 degrees plus the size of angle y equals to 180 degrees minus 50 degrees is 130 degrees. Here we will subtract 65 degrees from this equality, and we will get that y equals to 130 degrees minus 65 degrees is 65 degrees. So we found out that angle SRN, this angle, equals to 65 degrees. Okay. So in the next step we will focus on the right triangle SNR, the right triangle SNR, and the right triangle SMR. And we will actually prove that those two right triangles can go into each other. So, first of all, we have a common side, SR. Side SR is actually a common side. It belongs to both triangles, to the right triangle SNR, and actually SR also belongs to the right triangle SMR. Okay, so we can write down that SR equals to SR. SR equals to SR. It is a common side. It belongs to both triangles. And we also know that those two angles are right angles, therefore they are equal to each other. So angle SNR, this right angle, equals to angle SMR, this right angle. And both those two angles are right angles, and they are equal to 90 degrees. And we also know that those two angles are also equal to each other, and they are both equal to 65 degrees. So we can write down that angle NRS is equal to angle SRM or angle SMRS, angle MRS, again angle NRS This angle equals to angle MRS, this angle, and both angles are equal to 65 degrees. And we also have the rule that the sum of the angles in any triangle equals to 180 degrees. Okay? So, what is the size of angle MSR? Actually, the size of angle MSR in triangle MSR will be equal to 180 degrees minus the sum of the other two angles. 180 degrees minus 90 degrees plus 65 degrees. Again, that is actually the size of angle MSR, and it is actually also the size of angle NSR. Okay? Angle NSR, this angle also will be equal to 180 degrees minus 90 degrees minus 65 degrees. So angle NSR, this angle that equals to angle MSR, this angle will be equal to here 90 degrees plus 65 degrees is 155 degrees, and 180 degrees minus 155 degrees equals to 25 degrees. So we actually found out that the size of angle MSR, that also equals to the size of angle NSR, are both equal to 25 degrees. That is to say, angle MSR equals to angle NSR, and both angles are equal to 25 degrees. Okay, so we actually found out that three angles of the right triangle SMR are equal to the corresponding three angles of triangle SNR, and also we have a common side. Therefore, we actually proved that the right triangle SMR is congruent to the right triangle SNR according to side angle rule. So I'll write it down. So actually, triangle MSR, the right triangle MSR, is congruent. That is the sign of congruent. So the right triangle MSR is congruent to the right triangle NSR according to side angle rule. So what is angle side angle rule? Angle side angle rule states that if one triangle has two angles and the side that is attached to two angles that are equal to the corresponding two angles and the side that attached to these two angles, then you actually proved that those two triangles can go into each other according to angle side angle rule. Okay, so from the fact that triangle SMR, the right triangle SMR, is congruent to the right triangle SNR, we can conclude that those two sides are equal to each other. SM is equal to SN. SM is equal to SN. SM is equal to SN according to the rule that corresponding sides in congruent triangles are equal to each other. Actually, those two triangles congruent to each other, and the corresponding sides, that is to say SM and SN, will be also equal to each other. I repeat, triangle SMR is congruent to triangle SNR, therefore the two corresponding sides, that is to say SM and SN, will be equal to each other, according to the rule that corresponding sides in congruent triangles are equal to each other. So we found that those two sides are equal to each other. SM equals to SN. Okay? And it is given us in the question that SQ is equal to SP. So if we define SP as Y, then SQ will be also equal to Y. Okay? So in the next step, we will focus on the right triangle SMP. We will focus on the right triangle SMP, and the right triangle SNP. Okay? So in these two right triangles, actually we will prove that those two right triangles can go into each other. First of all, we have already proved that SM equals to SN. SM equals to SN according to what we have already proved. We also know it is given us in the question that SP equals to SQ. SP equals to SQ. It is given us in the question that SP equals to SQ, and actually also PM equals to NQ. PM equals to NQ. Actually, we will prove that PM equals to NQ. Why PM is equal to NQ? PM equals to NQ. PM is equal to NQ because of the fact that we have two right triangles. Triangle SMP, this triangle is a right triangle, and also triangle SNQ is a right triangle. Therefore, we can apply the Pythagoras theorem in those two right triangles. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So what is the value of PM according to the Pythagoras theorem? The value of PM according to the Pythagoras theorem is actually PM equals to the root of SP squared minus SM squared. Again, according to Pythagoras theorem, because we know that a triangle SMP is a right triangle, the value of PM equals to the root of SP squared, that is the hypotenuse squared, minus SM squared. Okay, that is the value of PM according to the Pythagoras theorem. And what is the value of NQ in the right triangle SNQ? The value of NQ is actually equals to the root of SQ squared minus SN squared. Again, the value of side NQ in the right triangle SNQ is equal to SQ squared minus SN squared. Okay? But we know that SP equals to SQ. SP equals to SQ, it is given us in the question that SP equals to SQ. Okay, here SP equals to SQ. And we also know that SM equals to SN. Here SM equals to SN. So you can see here SM equals to SN. We've already proved that SM equals to SN. Therefore, those two expressions are equal to each other. That is to say, PM equals to NQ. Okay, we found out that PM equals to NQ. So we actually succeeded to prove that the right triangle SMP can congruent to the right triangle SNQ according to side rule. So I will repeat again. Triangle SMP congruent to triangle SNQ according to side rule. So what is side rule? Actually, if you prove that three sides of one triangle are correspondingly equal to three sides of another triangle, then you actually proved that those two triangles can go into each other according to side rule. Okay? So, what we can conclude from the fact that triangle SNP can go into triangle SNQ? Actually, from the fact that those two right triangles can go into each other, we can conclude that angle SNP in triangle SNP, that angle SQN in triangle SQN is equal to angle NPR, this angle in triangle NPR. Okay, so we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Actually, those two right triangles can go into each other, therefore the corresponding angles, those two corresponding angles will be equal to each other. So I write it down. Angle SPM, angle SPM of triangle SPM is equal to angle SQN of triangle SQN according to the rule that those two corresponding angles in congruent triangles are equal to each other. Okay? And if we define angle SPM as theta, then angle SQR, you can, okay, this angle SQN will be also equal to theta because of the fact that those two angles are equal to each other. So we actually found out that angle SPM is equal to angle SQN, and both angles are equal to theta. Then we actually have a rule, I will call it rule number 1. Rule number 1 states that if a line segment subtends two equal angles, on the same side, then we can put then the 4 points lie on a circle. So I will read rule number 1 again. Rule number 1 states that if a line segment subtends two equal angles here, two equal angles. Again, if a line segment subtends two equal angles on the same side, then the 4 points lie on a circle. So, what is the meaning of rule number 1? We can actually see it from our drawing. In our drawing, we have two equal angles, that is to say, both those two angles are equal to theta, therefore they are equal to each other. So those two angles subtend on the line segment SR. Therefore, according to rule number 1, the 4 points S, R, Q, and P lie on a circle. Okay? So, we can put those 4 points, that is to say S, R, Q, and P, on a circle. So we will do it now. Actually, we will have a circle that actually blocks the quadrilateral SRQP, and points SRQ and P will be on that circle that I will draw. Or points S, R, P, and Q will be 4 points on the circle that I will draw. So here we have actually the quadrilateral SRQP will be inscribed in the circle that I will draw, and points S, R, P, and Q will be points on that circle. So actually, I will repeat on rule number 1 again. We have here two angles that are equal to each other. They are both equal to theta, and they lie on the same line segment SR. Therefore, according to rule number 1, the 4 points S, R, P, and Q lie on a circle. Okay, that is the implementation of rule number 1. The drawing is the implementation of rule number 1 in our drawing. Okay. So actually, quadrilateral SRPQ is inscribed in this circle. Again, quadrilateral SRPQ inscribed in this circle, and points S, R, P, and Q lie on that circle. And we have also rule number 2. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angle that subtend on the same chord are equal to each other. And of course we can implement rule number 2 in our drawing, in our circle. If we can see from the drawing that angle X subtend on chord PQ, and we can see also that angle PRQ, this angle that equals to 50 degrees, also subtend on the same chord PQ. Therefore, according to rule number 2 that states that peripheral angles that subtend on the same chord are equal to each other, we have those two peripheral angles X and 50 degrees that subtend on the same chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, X equals to 50 degrees. Again, X equals to 50 degrees according to rule number 2. Okay. According to rule number 2, if we have two angles that subtend on the same chord, they are equal to each other. Here we have angle X and angle PRQ that equals to 50 degrees that subtend on the same chord PQ, therefore they are equal to each other. That is to say, X equals to 50 degrees. So we found out that the value of X, or the size of angle X, is actually 50 degrees. So we actually finished with method 1. In the next step, we will find out the value of x according to method 2, or according to the second method. So in the second method, we will do a different construction. Actually, we will extend line segment SR and from point Q we will draw perpendicular to the extended SR. So here we will define the touching point between the extended SR line segment and the perpendicular that we draw from point Q. We will define it as M. Okay, so actually QM is perpendicular to extended SR. That is to say, this angle equals to 90 degrees. Okay. Then we will extend line segment QM in such a way that Q dash M will be equal to QM. Actually, the drawing is not correct, but you should assume that Q dash M is equal to QM according to our drawing. Okay? Then, 1 minute, I made a mistake. Actually, okay, so from point R, we will actually join together points Q and R by a straight line. And we will also join together points S and Q dash by a straight line. Okay. First of all, after we extended SR by a straight line, actually SM is a straight line, therefore the sum of the angles on one side of a straight line must be equal to 180 degrees. That is to say, if we focus at point R on the lower side, the sum of the angles at point R on the lower side on the straight line SM must be equal to 180 degrees. So 65 degrees plus 50 degrees plus the size of this angle, let's define this angle as Z, must be equal to 180 degrees. Okay, so we'll write it down that we know that actually SM is a straight line. So on the straight line SM if we focus at point R on the lower side of the straight line SM, the sum of the angles must be equal at point R at the lower side to 180 degrees. That is to say 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees. Okay, according to the rule that states that the sum of the angles on a straight line equals to 180 degrees, if we focus on the straight line SM at point R on the lower side of the straight line, 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees. Okay, here we'll subtract 50 degrees from this equality and we'll get that 65 degrees plus the size of angle Z equals to 180 degrees minus 50 degrees is 130 degrees. We'll subtract 65 degrees from this equality and we will get that Z equals to 130 degrees minus 65 degrees is 65 degrees. So we found out that the size of angle Z is 65 degrees. Okay. Actually, according to what is given us in the question, SP equals to SQ. So if we define SP as Y, then SQ will be also equal to Y. Okay, SP equals to SQ equals to Y. So that is according to what is given us in the question. So we found out that angle QRM, this angle equals to 65 degrees. So in the next step, we will focus on the right. First of all, we'll find out the size of this angle. We will define it as angle L. Again, we know that QM is a straight line and QQ this is also a straight line. Okay, you can write down that QQ this is a straight line, and we know that the sum of the angles along the straight line at any point is equals to 180 degrees. So if we focus at point M on the straight line QQ this, on this side of point M, we know that the sum of the angles must be equal to 180 degrees. So we have here 90 degrees plus the size of angle L must be equal to 180 degrees. Again, according to the rule that the sum of the angles on a straight line is equal to 180 degrees, so at the straight line QQ this, if you focus at point M, and on one side, at one side of point M, the sum of the angles must be equal to 180 degrees. So from this equality, we will subtract 90 degrees. So L equals to 180 degrees minus 90 degrees, L equals to 90 degrees. So we found out that angle L is a right angle. Okay, so angle L is a right angle. That is to say, it equals to 90 degrees. So, in the next step, we will focus on the right triangle QRM, and the right triangle QDES-RM. Okay? So we will focus on the right triangle QRM, and the right triangle QDES-RM. Actually, we will prove that those two right triangles can go into each other. First of all, we know that QDES-M is equal to QM according to our construction. Again, QM is equals to QDES-M according to our construction. Again, QM is equal to QDES-M according to our construction. We also know that those two angles are equal to each other. They are both right angles. Okay? So we can write down that angle QMR is equal to angle QDES-MR, this angle, and both angles are equal to 90 degrees. We proved that this angle equals to 90 degrees, and this angle is 90 degrees because from point Q we draw perpendicular to point M, therefore this is a right angle. So we actually proved that angle QMR is equal to angle QDES-MR, and both angles are equal to 90 degrees. And we also have here a common side. RM equals to RM. RM equals to RM. It is a common side. Actually, it belongs to both triangles. So I can write down that RM equals to RM as a common side. Okay, RM equals to RM as a common side. So we actually proved that the right triangle QRM is congruent to the right triangle QDES-RM according to side rule. So I'll write it down. Triangle QRM is congruent to triangle QDES-RM according to side rule. Okay, so what is side rule? Side rule states that if you prove that three sides of one triangle correspondingly are equal to three sides of another triangle, then you proved that those two triangles can go into each other according to side rule. And we actually proved the three sides of the right triangle QRM are correspondingly equal to three sides of the right triangle QDES-RM. Therefore, we proved that those two right triangles can go into each other according to side rule. of the fact that triangle QRM congruent to triangle QDES RM, we can conclude that first of all, those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So because of the fact that this angle is equal to 65 degrees, then this angle will be also equal to 65 degrees because of the fact that those two angles are equal to each other. So we can write down that angle QRM, this angle, is equal to angle QDES RM, and both angles are equal to 65 degrees. Okay, I'll repeat again. Angle QRM is equal to angle QDES RM, and both those two angles are equal to 65 degrees. You can see it from the drawing. Okay. And the second thing that we can conclude from the fact that those two right triangles can point to each other is that QR is equal to QDES RM. I'll write it down. QR is equal to QDES RM, QR is equal to QDES RM according to the rule that corresponding angles in congruent triangles are equal to each other. That is to say, those two triangles are congruent to each other, therefore those two corresponding angles will be also equal to each other. Okay? So, in the next step, we will focus on the right big triangle QMS. The right big triangle QMS, and the right big triangle QDES MS. And we will actually prove that those two right big triangles can go into each other. Okay? First of all, we know that QM equals to QDES RM according to our construction. QM QM is equal to QDES RM according to our construction. QM is equal to QDES RM according to our construction. We made QDES RM in such a way that it will be equal to QM. And we also know that those two angles are equal to each other. They are both right angles. So angle QMS, this angle is equal to angle QDES MS, this angle. And they are both equal to 90 degrees. I repeat, angle QMS is equal to angle Q decim S, and they are both equal to 90 degrees, and they also have a common side. SM is equal to SM as a common side. Actually, SM belongs to both triangles. So we can write down that SM equals to SM as a common side. So we actually proved the triangle SMR is congruent to the right triangle Q decim R according to side angle side rule. So I write it down. Triangle QMS congruent to triangle Q decim S triangle QMS congruent to triangle Q decim S according to side angle side rule. Okay, triangle QMS congruent to triangle Q decim S according to side angle side rule. So actually, what is side angle side rule? Side angle side rule states that if you prove that two sides and the angle between them in one triangle are correspondingly equal to two sides and the angle between them on the other triangle, then you actually prove that those two triangles can go to each other according to side angle side rule. And here we will actually prove that those two sides and the angle between them are correspondingly equal to those two sides and the angle between them. So we proved that triangle QSM is congruent to triangle Q decim S according to side angle side rule. Okay, so what we can conclude from the fact that the two big triangles can go into each other, we can conclude from it that SQ equals to SQ dash. SQ equals to SQ dash. SQ equals to SQ dash according to the rule that corresponding angles in congruent triangles are equal to each other. Those two big right angles can go into each other, therefore the two corresponding angles, that is to say SQ and SQ dash, will be equal to each other. Okay? So we found out that SQ equals to SQ dash. So if SQ equals to Y, then SQ dash will be also equal to Y. Okay? So in the next step, we will focus on triangles SRQ and triangle SRQ dash. Okay, we will focus on triangle SRQ and triangle SRQ dash. and we will actually prove that those two triangles can go into each other. Okay, we'll focus on triangle SRQ and triangle SRQ-. So we have already proved that QR equals to Q-. Again, we've already proved that QR equals to Q-. Okay, QR equals to Q-. And QR equals to Q-, and we know also that SQ equals to SQ-. We have already proved that SQ equals to SQ-, and they are both equal to Y. SQ equals to SQ-, and they are both equal to Y. Okay. SQ equals to SQ-, and they are both equal to Y. And we also have a common side, that is to say RS equals to RS, it belongs to both triangles. RS equals to RS is a common side. So we actually proved the triangle SRQ is congruent to triangle SRQ-, according to side rule. Okay? We proved the triangle SRQ congruent to triangle SRQ-, according to side rule. Okay? So from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. So write it down. We can conclude that angle SQR, this angle, is equal to angle SQ-. According to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be equal to each other. So if we define angle SQR as theta, then angle SQ-, R will be also equal to theta. Because of the fact that those two angles are equal to each other, so in the next step, we will prove that PQ- is a straight line. Okay, we'll prove that PQ- is a straight line. line segment, we will prove that line segment PQ this is a straight line. Actually, if we prove that at point R the sum of the angles is equal to 180 degrees, we actually proved that angle PRQ is angle that equals to 180 degrees. Therefore, PRQ dash will be a straight line. That is to say, PQ dash is a straight line. And if we focus at point R, the sum of the angles at point R is 50 degrees plus 65 degrees plus 65 degrees. 50 degrees plus 65 degrees plus 65 degrees is equal to 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees is 180 degrees. So we actually proved that the sum of the angles at point R is equal to 180 degrees at one side of point R, actually. At the lower side of point R, the sum of the angles is equal to 180 degrees. Therefore, we actually proved that angle PRQ dash is a angle PRQ dash is an angle that equals to 180 degrees. That is to say, PRQ dash is a straight line. Therefore, PQ dash is a straight line. Okay, actually, we proved that angle PRQ dash is an angle that equals to 180 degrees. That is to say, that angle that line segment PRQ is a straight line, and therefore PQ dash or line segment PRQ dash is a straight line. Therefore, PQ dash is a straight line. Okay, PQ dash is a straight line. Therefore, PQ dash is a straight line. Therefore, the structure PQ dash S is a triangle. The structure PQ dash S is a triangle. Again, PQ dash is a triangle. PQ dash is a triangle. PQ dash S is a triangle. So in triangle PQ dash S, we have two sides that are equal to each other. actually SP equals to S cubed S equals to Y. Again, in triangle P cubed S, we know that SP equals to S cubed S equals to Y. Therefore, according to the rule that in front of equal sides in the triangles we have equal angles, that is to say, in front of those two sides that are equal to each other, we have equal angles. Those two angles are located in front of the equal sides, therefore they are equal to each other, and because of the fact that this angle is theta, then this angle must be also equal to theta. According to the rule that in front of equal sides in the triangle there are equal angles. In front of those two angles there are equal sides, therefore those two angles are equal to each other. So if this angle is theta, then this angle will be also equal to theta. And from this point we will continue according to method 1. In method 1 we use rule number 1. It states that if we have two angles that subtend on the same segment line from the same side, then we can put the 4 points, or we can say that the 4 points S, R, Q, and P lie on a circle. So you can see from the drawing that those two angles that are equal to each other, they are both equal to theta, and they subtend on line segment SR. Therefore, according to rule number 1, points S, R, Q, and P lie on a circle. So we actually can draw a circle with points S, R, Q, and P on that circle. Okay, so we will draw a circle with points S, R, Q, and P. Okay. So again, I will repeat on rule number 1. Rule number 1 states that if you have if you have two equal angles that lie on the same line segment, then those two 4 points S, R, P and Q lie on a circle. As you can see from the drawing, we have those two angles that are equal to each other. They are both equal to theta, and they lie and they subtend on the same they subtend on the same chord, or those two angles subtend on the same line segment SR from the same side. Therefore, according to rule number 1, points SR, P and Q lie on a circle. So we have here a circle that points SR, P and Q lie on that circle, and we can see from the drawing that angle X subtend on chord PQ, and angle PRQ subtend also on the same chord PQ. And according to rule number 2, if two peripheral angles subtend on the same chord, they are equal to each other. So we have two peripheral angles. Those two peripheral angles subtend on the same chord PQ, therefore they are equal to each other according to rule number 2, that is to say X equals to 50 degrees. So we found out that X equals to 50 degrees according to rule number 2. So we found out that the value of X is also 50 degrees according to the second method. So in the next step, I will summarize the lecture. Actually, we wanted to find out the size of angle X, and we know that angle SRP, this angle equals to 65 degrees, angle PRQ equals to 50 degrees, and side SP equals to side SQ. And we want to find out the value of angle PSQ, that is to say angle X. Okay? So, according to the first method, we actually extended QR, and then from point S we draw perpendicular to extended QR, so this angle is 90 degrees. This point is point N, and from point S we draw perpendicular also to PR. So the perpendicular SM creates 90 degrees with PR. This angle is 90 degrees, and this angle is also 90 degrees. Then actually, after we extended QR by a straight line, actually we know that QN is a straight line, and the sum of the angles of the straight line QN at point R must be equal to 180 degrees. So this angle is 50 degrees, this angle is 65 degrees, so this angle must be equal to 65 degrees in order to complete the sum of the angles at point R from this side of the line, the straight line, to 180 degrees. Okay, it is actually from my point of view, it is from the left side of the straight line QN, or according to, as you can see it, it is from the right side of the straight line QN. The sum of the angles must be equal to 180 degrees. Therefore, this angle SRM, must be equal to 65 degrees in order to complete the sum of the angles to 180 degrees. So this angle equals to 65 degrees. And then we know that so this angle equals to 65 degrees, and then we actually focused on the right triangle SNR, and the right triangle SQR. SQR and SNR. We actually focused on the right triangle SNR, this right triangle, and the right triangle SMR. We proved that those two triangles can go into each other. First of all, we know that SR is a common side. It belongs to both triangles, so we can write down that SR equals to SR. Then we know that those two angles are equal to each other. They are both right angles, therefore they are equal to each other. And we also know that those two angles are both equal to each other. They are also equal. They are both equal to 65 degrees, and they are equal to each other. And because of the fact that we have two angles, that one angle is a right angle and the other angle is 65 degrees, and we know that the sum of the angles in any triangle equals to 180 degrees, so the third angle must be equal to 25 degrees in order to complete the sum of the angles in the triangle to 180 degrees. So those two angles are both equal to each other, and they are both equal to 25 degrees because of the rule that states that the sum of the angles is 180 degrees on a triangle, and we have already angles that equals to 90 degrees and 65 degrees, so in total we have two angles that the sum of them is 155 degrees, and in order to complete the sum of the angles in the triangle to 180 degrees, this angle must be equal to 25 degrees. Exactly as the same this angle, so this angle are equal to each other, those angles, and they are both equal to 25 degrees. So we actually proved that those two right triangles can go into each other according to angle side angle rule. Okay? Then we focused on those two right triangles, triangle SMP and triangle SNQ, and we proved that those two triangles can go into each other. Actually, from the fact that those two triangles can go into each other, we actually concluded that SM equals to SN. Okay, and then we proved that the right triangle SMP is congruent to the right triangle SNQ. Why? Because we know that SM equals to SN. We know that SP equals to SQ, it is given us in the question, and actually PM equals to QN. Why PM equals to NQ? Because we have here two right angles, and we can calculate the value of PM according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So according to the Pythagoras theorem, the size of PM is actually equals to the root of SP square minus SM square. Okay, that is the size of PM, and the size of QN according to the Pythagoras theorem in the right triangle SNQ, NQ will be equal to the root of SQ square minus SN square. NQ will be equal to the root of SQ square minus SN square. Okay, but we know that SP equals to SQ, it is given us the question, and we have already proved that SM equals to SN. So actually those two expressions are identical, so that we can conclude that MP equals to NQ. So we actually proved that the right triangle SMP can go into the right triangle SNQ according to side rule. For the fact that the two right triangles can go into each other, we can conclude that those two angles are equal to each other. According to the rule that corresponding angles in congruent triangles are equal to each other. And if one angle is theta, then the other angle will be also equal to theta because of the fact that they are equal to each other. And then we have rule number one. Rule number one states that if a line segment subtends two equal angles on the same side, then the 4 points lie on a circle. So we have here two angles that are equal to each other, they're both equal to theta, and they subtend on the same line segment SR. Therefore, according to rule number one, points S, R, Q, and P lie on a circle. Okay, points S, R, P, and Q lie on a circle, and that is according to rule number one. And we also have rule number two that states that peripheral angles that subtend on the same chord, peripheral angles that subtend on the same chord are equal to each other. We can implement rule number two in our drawing, because in our drawing we have angle X that subtend on chord PQ, and we have angle PRQ that equals to 50 degrees that also subtend on the same chord PQ. Therefore, according to rule number two, those two peripheral angles are equal to each other. That is to say, X equals to 50 degrees. So we found out according to the first method that the side of angle X is actually 50 degrees. Okay, so we finished with the first method, and then we found out the value of X according to the second method. Actually, in the second method, we extend that line segment SR, and then from point Q we draw perpendicular to M. That is to say, QM is perpendicular to extended SR. That is to say, this angle equals to 90 degrees. And then we extended QM in such a way that MQS will be equal to QM. Although you cannot see it from the drawing, but that is what we actually did. We extended QM in such a way that Q dash M will be equal to QM. Okay? And after we extended S after we extended SR, we created SM. We extended SR by a straight line, therefore SM is a straight line. And we know that the sum of the angles at one side of straight line equals to 180 degrees. So if we focus at point R on the lower side of SM, the sum of the angles must be equal to 180 degrees. That is to say 65 degrees plus 50 degrees plus the size of this angle must be equal to 180 degrees. And okay, 65 degrees plus 50 degrees plus the size of angle Z equals to 180 degrees. From this simple equality, we got that Z equals to 65 degrees. So we found out that this angle equals to 65 degrees. Then we actually proved that this angle equals to 90 degrees. Actually, here Q this is a straight line, therefore the sum of the angles at one side at point M must be equal to 180 degrees. That is to say 90 degrees plus the size of this angle equals to 180 degrees. Okay, 90 degrees plus angle L must be equal to 180 degrees. Here we subtracted 90 degrees from this equality and we got that the size of this angle L is 90 degrees. That is to say this is the right angle. Then we focused on the right triangle QMR and on the right triangle QDSMR, and we proved that those two right triangles can go into each other. First of all, we know that QM equals to QDSM according to our construction. We also know that those two angles are equal to each other. They are both right angles, they are equal to 90 degrees. And we also have a common side, that is to say RM equals to RM. It belongs to both triangles. Therefore, we actually proved that those two triangles can go into each other according to actually side angle side rule. According to side angle side rule. For the fact that those two right angles can go into each other, we can conclude that those two angles are equal to each other, and because of the fact that this angle equals to 65 degrees, then this angle must be also equal to 65 degrees. And we also can conclude from the fact that those two right angles can go into each other, that QR equals to Q desar. Okay, QR equals to Q desar. According to the rule that corresponding angles in congruent angles are equal to each other. Then we focus on the two right big triangles, triangle QMS and the right big triangle, triangle QDSMS, and we prove that those two triangles can go into each other. First of all, we know that QM equals to QDSM according to our construction. We also know that those two angles are equal to each other, they are both equal to 90 degrees. Okay, and we know that SM equals to SM, it is a common side, it belongs to both triangles. So we actually proved that those two big right triangles can go into each other according to side angle side rule. Okay, for the fact that those two triangles can go into each other, we can conclude that SQ equals to SQ dash. SQ equals to SQ dash, and if SQ equals to Y, then SQ dash will be also equal to Y, and actually also SP equals to SQ, so SP also equals to Y. And then we focused on triangle SRQ, this triangle, and triangle SRQ dash, and we proved that those two triangles can go into each other. Actually, we know that QR equals to QDSR. We have already proved it. We also know that SQ equals to SQ dash, we have already proved it, and RS is the common side, RS equals to RS, it belongs to both triangles. So we actually proved that those two triangles can point to each other according to side rule. And from the fact that those two triangles can point to each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. And because of the fact that and if one angle equals to theta, then the other angle will be also equal to theta. Okay? Then we actually proved that PQ dash is a straight line. How we proved that PQ dash is a straight line? We actually proved that angle PRQ dash is angle that equals to 180 degrees, and therefore PRQ dash is a straight line, that is to say PQ dash is a straight line. And why PRQ dash is a straight line? Because 50 degrees plus 65 degrees plus 65 degrees equals to 180 degrees. That is to say, angle PRQ dash is angle that equals to 180 degrees. So PRQ dash is a straight line. That is to say, PQ dash is a straight line. Okay? And because of the fact that PQ dash is a straight line, we can conclude that PSQ dash is a triangle. Okay? PQ dash S is a triangle, and the triangle PQ dash S, we know that PS equals to SQ dash, and they're both equal to Y, and we have a rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles are equal to each other, and because of the fact that this angle equals to theta, then this angle must be also equal to theta because of the fact that those two angles are equal to each other. And from now on, from this point, we continued according to the first method. We have here two equal angles that subtend on the same segment line SR. Therefore, according to rule number 1, the 4 points SR, Q, and P lie on a circle. Okay, those two angles subtend that equal to each other subtend on the same segment line SR. Therefore, points SR, P, and Q lie on a circle. Okay, so this is the implementation of rule number 1 in our drawing. So we have here two peripheral angles that are equal to each other. We have here two peripheral angles that subtend on the same chord, that is to say on chord PQ, and therefore, according to rule number 2, peripheral angles that subtend on the same chord, they are equal to each other. Here we have angle X and angle that equals to 50 degrees subtend on the same chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, X equals to 50 degrees. So we found out, according to the second method also, that the size of angle X is 50 degrees. Again, this angle, the size of this angle, angle X, is actually equal to 50 degrees. You can write here that X equals to 50 degrees. And that is the answer to the question. So we found out that the size of angle X is equal to 50 degrees according to both methods, both method number 1 and method number 2. Okay, so that is the answer to the question. According to both methods, we found that the size of angle X equals to 50 degrees. Okay, thank you very much.